Alright, good morning everyone. Today we're going to be looking at areas of circles and sectors. Just like the last section, we're first going to look at the areas of circles and then we're going to look at the areas of sectors. It's going to end up being pretty much the same formula as we had done there, but we are going to have to add 2 here. So let's write them down right away. Alright, so the first thing we need to do is actually know the area equation for a circle. Now there's only one. So whenever I hear area of a circle, I know which equation to use. Instead of having circumference, do I use 2 pi r or pi d? I always use 2 pi r. Personal preference. However, for a circle, we know that the area is pi times the square of the radius. Or in other terms, pi r squared. So if I look at this circle that I have up there, the area would be equal to pi times 6 squared, or area equals 36 pi units squared. And that's all there is to it, because the radius is 6, I plug it in, and I get the area. So let's again look at a slide and find the area and diameter in certain circumstances. So I'm given basically 4 different situations. So I'm going to draw 4 circles up here. The 2 on the left, they're looking for the area. The 2 on the right, they're looking for the diameter. Alright, so the first problem, it says the diameter of the circle is 5 centimeters. So I know that the diameter is 5 centimeters. So that would mean the radius is 2.5 centimeters because it would be half the diameter. And if I'm looking for the area of the circle, now the area equation for a circle is a equals pi r squared. So pi is pi, r is 2.5, so 2.5 quantity squared. 2.5 centimeters quantity squared. 2.5 squared is 6.25. Multiply that by pi. Calculator time, 6.25 times pi. You get something real close to 19.63 centimeters squared. Now, you notice how I went right away to the area. It's because I don't like decimals in pi. If it was a whole number like 6 pi centimeters squared, I'd have been fine. However, because it was 6.25 pi, I'm already partially in decimals, so might as well just go and round it. So the area in this case is 19.63 pi. Sorry, 19.63 centimeters squared. Alright, next circle. I'm still trying to find the area. So right away, throw down the area equation. A equals pi r squared. Well, the radius of this circle is 7 inches. So A equals pi times 7 inches squared. 7 squared is 49. I'm fine with you leaving your answer as 49 pi inches squared. However, if it's a word problem or if I ask you to round, plug in your calculator real quick and tell me at least to the 100th. Area equals 153.94 inches squared. And there we go. That's how I would find area for each of these. Alright, so over here, I tell you the circumference of the circle is 10 pi. So circumference is 10 pi. Hold up. This is to see if you're paying attention. Now, if you would have thrown down a equals pi r squared, we did it wrong. Because I'm given circumference, I'm going to use the circumference equation. For me, that almost always means I'm using 2 pi r. I know the circumference is 10 pi equals 2 pi r. Divide both sides by 2 pi, r equals 5, and there was no length, so 5. So the diameter is 10. This was a little bit of a review. I was just trying to see if you were paying attention and making sure that you were using the right equation. Alright, but for the next problem here, I tell you that the area is 28.26 inches squared. So this one you know right away to throw down a equals pi r squared. Try to find r first, so I know the area is 28.26 inches squared equals pi r squared. First thing I have to do, divide both sides by pi. So 28.26 is a number real close to 9. 8.995 inches squared. Square root both sides. R is Even when I'm using the full number, I get 2.9992, or r is 3 inches. So that means the diameter is 6. So these type of problems shouldn't be too bad. If you're looking for the area, or you have the area and you're trying to solve, so you pop down the equation, you plug in what you need to know, and you solve. If it's a number like this where it's a whole number times pi, you can usually leave it like that unless I ask for a decimal. Alright, so now we're going to go on to a little bit tougher part of this. We're now no longer looking at just the whole circle. We're looking at just part of it. And what if we were trying to argue, for instance, somebody cut the pizza, and you wanted to make a scientific argument or mathematical argument on that they actually have the bigger piece. And they might say, well, yours is longer and thinner. Mine was just thicker and shorter. So you actually had more pizza or pie than me. Well, there's actually a way to find that. And that's by finding the area of a sector. This would be how you would try to argue, no, you actually had more pie than me, or no, you actually had more pizza than me. You're not being fair. Is by calculating the area of a sector. I wonder how many of you will actually go home and measure. Probably not many. But anyway, a sector is a part of a circle formed by a central angle and its arc. So it's like a slice of pizza. So if I would look up here and I drew up a circle, and I was looking at a slice of it, like that right there. This here is the sector. It's the part of the circle formed by the central angle and its arc. So it's actually the slice of pizza, the slice of pie. And just like before, how I find it is that the measure of the arc, AB, will equal 360 degrees. Sorry, 360 degrees will equal the area of sector APB. So let's start putting A, P, and B up here. APB to the full area. So again, we're taking part to part equals part to part. Now, the weird thing here, if you ask me, is back in section 3, we had looked and said, all right, if we do a ratio of areas, we have to make sure that this ratio over here is of the areas. But for some reason, it works out that the ratio of the measures equals the ratio of the areas. And I find that surprisingly unique, because in that other section we had to worry, like, does length to length? No, I have to do length squared to length squared. But it ends up being here that the slice in terms of measure will be the slice in terms of area. It also ended up being the slice in terms of measure equaled the slice in terms of length along the edge. It's pretty neat how it works. Alright, by the way, most of the time I'll be labeling this part as X just because that's a lot of writing. I'll put in my middle of my picture, alright, I don't want to write area of sector APB, so we're going to call it X. Just so that way it's nice and easy for us. Alright, so you see I have added 2 more equations for us. So what if I started with this and I just said find the area of the given sector? It's the same 2 circles from the last one, but now I'm just looking for the area of their sectors. Alright, by the way, a sector has to have the middle point be the center of the circle. So we actually name it by the 2 points on the arc and its center angle. We're going to do just 1 circle at a time, so I'm going to draw only the A, or circle D to start with. Circle D is here. Up, right, down here. This is a 90-degree angle. We know this is 8 feet. A, B, C. Alright, the first thing they want me to do is find area of sector BDC. BDC, it's right here. I'm going to call that area X. And I know from my equation, I'm going to do the measure of the arc, which happens to be 90 degrees. So I'm going to compare 90 degrees to the full circle, 360 degrees. That will equal the area of my sector X to the area of the full circle, pi r squared. So, measure of the arc, 90 degrees, to 360, equals the area of the sector I'm looking for, x, to pi r squared, pi 8 feet squared. I'd reduce, again, just like I was doing yesterday, 1 to 4 equals x to 64 pi feet squared. Cross multiply, 4x equals 64 pi feet squared. So x is going to be equal to 16 pi feet squared. And I'd be fine with this answer here. However, write it as area of sector BDC equals 16 pi feet squared. By the way, area of is for each of these. Alright, go ahead and try number 2. See if you can get this set up. So I filled in what would automatically be true. Sector ADC. So ADC is this one down here. But let's use a different variable so that way you don't get confused on your homework. This is going to be y. Now, the radius is still 8 feet, so I know that goes here. Now, the measure of this arc, it wasn't mentioned, but these two arcs have the same length, so they're congruent. And if you remember back to yesterday, if this is 90, then the big thing is 270. Half of 270 is 135 degrees. So this is the same circle from yesterday. If you want to know how I got 135, just look back yesterday real quick. So 135. Let's again do reducing. So 3/8 equals y to 64 pi feet squared. Cross multiply, 8y equals 192 pi feet squared. Divide both sides by 8. And I think I get 24 pi feet squared for the area. So the area of this sector is 24 pi feet squared. Alright, so if you got the setup right, good job. If you got the final answer, even better. Alright, time to draw the other circle. I went ahead and filled in some extra information. Now, if I'm looking for the area of sector EFG, so EFG, it's this area right here. So automatically, I know to set up my proportion. 360 and pi r squared are guaranteed because it's the area of the sector. R in this case is 12 feet. Again, if you want to find out how I watched yesterday's. The area of the sector I'm looking for, that's actually what I'm looking for, so let's put x. The measure of that arc is 150. Again, I found this yesterday. It's the same circle as yesterday. But the measure of that arc is 150 degrees. Oh, so the measure of the arc to 360 equals x to the area of the circle. Okay. Simplify again. 5/12 equals x over 144 pi feet squared. Cross multiply, 12x equals 720 pi feet squared. Divide both sides by 12, x equals 60 pi feet squared. Again, you might be plugging this in the calculator and give me a rounded answer, but if they don't require it, 60 pi feet squared is a perfectly fine answer for me. Go ahead and try the last one on your own. Arc GFH. I'm just going to quickly identify that for you. It's this one right here. So again, I automatically filled in what I knew was going to be true. The radius is still 12, so I plugged 12 in for this. I'm looking for the sector, so that's x right there, and the measure of the arc is 30 degrees. Now that everything's been filled in, it's time to just solve. Reduce, so 1/12 equals x to 144 pi feet squared. Cross multiply, 12x equals 144 pi feet squared. X equals 12 pi feet squared. So if you did do this correctly, that's what you should have got. 12 pi feet squared. So there we go. This is how you find the area of the sector. Yeah, this is not the easiest thing to do. But if you get used to the setup, you'll probably get it right. It's just a lot of proportions again. So let's look at a real life example of this. What if you're a window maker or you're a painter for glass and you just need to figure out how much paint you need, but you have this weird shape. Maybe it's part of a basketball court and you're wondering, all right, we want to fill in the entire penalty area, penalty box with paint. How much paint do we need? So they give us some information in our picture, and right away I know it's picture information, so I'm going to try and draw the shape to the best of my ability. Alright, for a local competition you are required to paint windows. The shape of your windows is like the one pictured below, or like this. The radius of the semicircle is 20 inches. So there's a semicircle here at the top. They tell me that the radius is 20 inches, which means the full length here would be 40 inches. Okay, filled in what I knew. The full height of the window is 54 inches. So from top here to bottom is 54 inches. Which means this length here is 34. What is the area you have to paint? Well, if I remember back, all the way back to section 1, I can find the different areas here. So I could find the area of X and I could find the area of Y. And I could just add those two together. So let's do that. Let's find the area of X first. Well, that's the measure here. It's a semicircle. The measure of a semicircle is 180 to 360. The area of the sector is what I'm looking for, X. Pi r squared, r is 20 inches. So when I set this up to find the area of X, that's what I get. Do some simplifying. 1/2 equals X to 400 pi inches squared. Cross multiply. 2x is equal to 400 pi inches squared. So X is 200 pi inches squared. And I think it would make sense here to plug it into the calculator. 628 inches squared. Alright, to find Y, it's a rectangle. Wait, it's a rectangle? So the area of a rectangle is base times height. The base is 40 inches. The height is 34 inches. So when you multiply these two, you get, I'm not sure off the top of my head, 1,360 inches squared. Wait. So the total area that I'm looking for has to be those two combined, 1,360 plus 628. By the way, that one's wrong. So this is going to be real close to 1,988 inches squared. Or real close to 2,000 inches squared. And that's it. So, to find the area of a sector, we're setting up a ratio again. Measure to measure, area to area. And you cross multiply and solve. That is all I have for today. Till next time.